I am Hanamichi Sanada from the University of Electrocommunications, Japan. The title of my presentation is Investigation of Effective Parts for Rotation and Translation of the Legs using Hanger Reflex. All of those applications convey information about the direction in which the body moves and are called physical navigation. This navigation information is transmitted by the five senses such as sight, hearing, vibration, and tactile sensation. However, these methods are sometimes difficult to understand intuitively. To solve this problem, several methods have been proposed to induce actual movement of the leg. Various methods have been proposed for leg rotation and translation. Methods of actually moving the leg include inducing leg rotation and by using electric stimulation and by using a flywheel. Skin shear deformation is included when imparting the force sensation. However, these methods have problems such as being unable to withstand a small effect amount such as the amount of rotation and movement, ineffective if not moving, and being unable to wear on clothing. There is a method that enables walking navigation by the force phenomena that actually moves the body. It is a waist hanger reflex. This is a procedural force sensation method using skin shear deformation, and it is a method that has solved some of the problems described. However, since the method controls walking and rotating the upper body, it is not suitable for giving different teaching to the left and right separate legs for sports applications. We propose to use hanger reflex on foot as a new method of navigation that does not require interpretation of navigation information. This method can give different teaching to each foot. The hanger reflex is a tactile illusion phenomenon in which a wire hanger placed on the head induces involuntary rotation. As the illusion is quite strong and it can be achieved with very simple device, it is quite ideal way to control out the body. This phenomenon not only generates a force sensation but also accompanies a real motion such as a head rotation. Based on the principle of hanger reflex, we created devices for not only the head but also the wrist, waist, and ankles. This confirmed that the phenomenon similar to the hanger reflex occurred in the waist, head, wrist, and ankle. This time, we focused on the hanger reflex of this foot part. Our final goal is to create a universal hanger reflex device that actually produces body movements. The problem is where to make the hanger reflex occur if you want to effectively perform the necessary foot operations when working or teaching sports. In this paper, we investigated which part of the foot is most effective in causing the leg hanger reflex. The following are the indispensable items in the study of the leg hanger reflex. The effect amount of the hanger reflex was judged by the rotation angle amount and the translation amount. These are the necessary movements when actually moving the foot. Two factors are measured using an optical motion capture system. Considering the range of motion of the foot, the location of the hanger reflex was set at 4 points: thigh, knee, shin, and ankle. Because the size of each part was greatly different, we created devices of the size that fit each. The hanger reflex device adapted the belt types as made from previous research. A pneumatic actuator and balloon were used to dynamic generate hanger reflex. The system configuration is as shown in the figure, and the system that inflates a pneumatic balloon is used to generate hanger reflex. Preliminary experiments adjusted a balloon size and air pressure. The combination of how to inflate the balloon and the intended movement direction is as shown in the figure. These were created based on the results obtained from previous studies on the dynamic control of the hanger reflex at other sites. In previous experiments, the legs actually turned and translated in this way. The experimental environment is shown in the figure. The subjects are in an upright state, blind, stepped on the left foot, and the hanger reflex on the right foot. First, we examine which part of the leg was most effective to generate the hanger reflex from the viewpoint of the amount of rotation. Experimental conditions are as described. In experiment 2, the translational movement at fourth site was measured. The experimental conditions were the same as in experiment 1. Experiment 1 shows the result of the rotation angle. The vertical axis is rotation angle, and in the case of the right rotation of orange, a positive value means that it turns to the right side, and the negative means that it turns to the left side. The Yuki-Kramer method was used for multiple comparisons, and significant differences were found for all regions of the knee compared with other regions. This is a graph about the translation of experiment 2. The vertical axis is the translation amount and the horizontal axis is the presentation position. Yuki-Kramer method revealed significant differences in the relationships between the knee and other parts of the legs. The hanger reflex at the knee was found to be significant. The average rotation angle of the right rotation at the knee was 46.8 degrees, and the average left rotation was 40.6 degrees. This showed a large rotation angle compared to the results of previous studies using electrical stimulation under almost the same conditions. The knee moves the most in all directions. The reason why the difference in the amount of movement was significantly confirmed depending on the direction of movement can be considered to be the factor of the movable range of the legs, similar to the fact that the inside rotation angle was measured small duration rotation. From 2 experiments, it was found that wearing the device on the knee was most suitable for both the rotation and translation presentation. Possible reasons are described below. Future applications include teaching for sports that control both feet, such as skiing or walking navigation.